This will be our last video for 6.4 for establishing identities. Now, on the notes, you can see we have several examples. And what I'm going to do is I'm just going to go over three of them, and then I'll post the solutions on D2L so you can try on your own. I just think it might be a very long video if I'm doing all of these. So it's up to you. You can gauge if you're getting it, great. You don't have to look up the solutions. Or if you're, still struggling, try them and then look up the solutions. Okay, so looking at example C, we have cosecant theta minus cotangent theta equals sine theta over 1 plus cosine theta. Now remember, the rules are you can only manipulate one side, and you typically want to choose the messier side. Now, these are kind of equivalent in my mind. However, I do think it's easier to mess with two terms to combine to be one term. All right, so I'm going to rewrite cosecant theta minus cotangent theta to let the reader know that's what I'm messing with. And somehow I have to end up with sine theta over 1 plus cosine theta. So you just start thinking and you're like, okay, well, if I need to combine these two things to be one thing, that means they have to have a common denominator. So I'm going to rewrite these things using those quotient identities. Well, I know cosecant theta is 1 over sine theta. And cotangent theta is cosine theta over sine theta. Well, we got lucky here. This won't always be the case. They're already over the same denominator. So I can just put it as 1. But that is not what I need to end up with. And this is where that technique is going to come into play that we talked about that most likely felt weird. And you're like, how in the world did she think of this? But it's just a new technique. It was in the first example we did. Notice how we changed 1 plus cosine theta to look like sine theta. And this is this tool that if you see often enough, you will be able to use it on your own. Well, because I want somehow for sine theta in the denominator to turn into 1 plus cosine theta, well, I'm going to introduce it. So I'm going to multiply, let me do a different color, 1 plus cosine theta over 1 plus cosine theta. So this is known as the conjugate. So it's the conjugate of 1 minus cosine theta. That just means they're the same terms, opposite signs. Just one term is opposite. But also this piece gave it away. If I want to end up with that, maybe I should introduce it into the problem. Okay, well, I'm going to go ahead and FOIL the numerator. And I get 1, and I'm going to do it step by step so I don't lose you. 1 minus cosine theta plus cosine theta minus cosine squared theta. That's by FOILing. And I'm going to leave it like this, only because I know where it's going. You might not know that and distribute it out, and then you're just creating an extra step because you'll have to factor it. In that numerator, these two terms cancel out. You get 1 minus cosine squared all over sine theta times 1 plus cosine theta. So we're pretty close. So here's your other thing to pay attention to. In the numerator, I have to end up with sine theta. Well, doesn't this guy look like something on our list of identities? And you would take a look at it, and that actually equals sine squared. So there is something, you might really fight me on this, but that is really fun about this. It's like a big puzzle. And it's like all these pieces being substituted in. Well, now I have sine squared. Well, I can reduce that with one of these guys. And so I end up getting sine over 1 plus cosine theta. And if I look, is that where I wanted to end? Sure is. So you've completed your proof. We sometimes will write QED, means you proved it. It's Latin. And then this is another little more bang for your buck. We use this symbol. It means therefore. We showed cosecant theta minus cotangent theta equals sine theta over 1 plus cosine theta. You do not have to do this step. It was just a little more information for you if you want it. Okay. So now we're going to go to do a next example. All right, so let's do example D. All right, now I have sine squared theta minus tangent theta over cosine squared theta minus cotangent theta. And somehow this crazy looking thing is supposed to end up with tangent squared theta. So this one, I think it's pretty clear what the messier side to mess with is. So I'm going to rewrite that messy side. Okay. So we want to end up with tangent squared. So let's go ahead and start thinking. Well, maybe I want to, and I'm completely shooting in the dark here, and this is how you're going to have to do it as well. Well, I know I can replace tangent and cotangent in terms of sine and cosine, so I'm going to do that. So I'm just going to rewrite sine squared, but I know, and maybe I'll change colors so I don't lose you, that tangent's definition is sine over cosine. And then that whole thing is over cosine squared minus, and this guy's definition is cosine over sine. So right now, pretty darn close, because if you just look here, sine squared divided by cosine squared, that is tangent squared. So somehow I have to, I'm not that close, but I don't know. It seems like I'm going in the right direction. Okay, now here is where your algebra is going to come into play, and if I lose you, I really want to encourage you to reach out to me because you don't want your algebra to be what holds you back. You want to make sure these skills are really, really strong before you go further in mathematics. So you can go ahead and find a common denominator. We can go ahead and multiply whatever we want as long as it's 1. So for me, I want to reduce out this piece. Okay, so I'm going to multiply numerator and denominator by cosine theta. So I might be taking a longer step. We can all come up with different ways, so you just have to make sure you're clear with all your steps so I can grade it accurately. Okay, so let me see. Then I get sine squared minus sine cosine. Oh, forgive me. That's not necessarily true because this guy has to go here and here. So I get sine squared theta cosine theta minus just sine theta, right? Because these would reduce out. All right, then in the denominator, it's not going to be pretty, but I get cosine squared theta. Well, forgive me, actually, if I go ahead and multiply that, it'll be cubed. And then this one is minus cosine squared over sine. Okay, stick with me. all right? And again, there might be an easier way than the one I'm thinking of. Okay, well, I still have like a fraction within a fraction. I really don't want to deal with that. So I'm going to multiply top and bottom by sine. And we end up getting, I distribute sine to both terms. So I get sine cubed cosine theta minus sine squared theta. And then here, again, going to both terms, I get cosine cubed, times sine theta, minus, well, the whole purpose of introducing this was to reduce those guys out. So I get minus cosine squared theta. Okay, it's not looking like tangent squared yet. However, I can go ahead and factor. Well, what do these two terms share in common? It looks like sine squared. So then I get sine theta cosine theta minus 1. And then if I factor that denominator, I'm going to get cosine squared theta. Well, this is going to be cosine theta sine theta minus 1. And this is where I love this section so much because it's really cool when it starts to come together. You're like, oh my goodness, this and this are exactly the same. Order doesn't matter because it was multiplication, so that's why these reduce out. So then you get sine squared over cosine squared. Yay, that actually does equal tangent squared. So the key thing with these is you show every single step so I can follow what your brain is thinking, because your brain is going to think something differently than I think. But as long as your algebra steps are valid and you're using true identities from our list of identities, then you'll get full credit. But if you jump a bunch of steps and I can't figure out how you got there and it seems like magic, I have no idea what happened. Okay, we're going to do one more. And then again, if you want to try the last two on your own, please do, and then just check D2L for the answers. Okay, E. This looks very similar, going back up, to the very first one we started with. It looks really similar. So neither side is clear on which one is more messy. So it just depends on whatever you want. So I'm going to just start with the left side. Well, remember, this is just a tool. This is your third time seeing it, so hopefully you'll retain it at this point. I somehow have to get this cosine theta to spit out 1 plus sine theta. And I can't replace cosine theta with anything because it's not on my list. I mean, I could do 1 over secant, but that doesn't make sense since our end result doesn't involve secant. So that's your indication that you want to introduce it to the problem. So I'm going to multiply top and bottom by 1 plus sine theta. I'm not changing the problem at all. And then when you distribute, you get cosine theta times 1 plus sine theta. Now, this is my hint to you, is if I have to end up with this, well, here it is. So I probably don't want to FOIL it out because you're just going to have to end up factoring if you do. But in the denominator, I am going to FOIL. And again, that gets better with time. You might end up FOILing when you don't have to. And that's okay because that's what you're learning right now. If I FOIL that, I get 1 minus sine squared theta. Well, what is 1 minus sine squared theta? You got it, hopefully. It's cosine squared theta. Well, then this would reduce with one of these, And what do you know? We end up with what we need. So much fun. So that's perfect work. Or you can go further and say therefore, and you can just write out the identity you just proved. Not a necessary step, but just if you're going on upper level mathematics, it's cool to see that now. Okay, see you next time.